In order to sketch the normal curve 1 and 2 standard deviations from the mean, we first need our normal curve on our number line, and then we're going to draw a line directly down the center, and that's going to represent my mean. So x bar equals 95. Now, 1 standard deviation to the right would mean that I'm going to add 12 to 95, and at this line, 1 standard deviation to the right is going to mean that it's 107. 1 standard deviation to the left is going to be the average, that 95 minus 12, which is going to leave me with an 83. So within 1 standard deviation goes from 83 to 107, but 1 standard deviation to the right is this width, 1 standard deviation to the left is this width. So this measures 2 standard deviations, but when you say something is within the first standard deviation, it means within these 2 lines. To get to the second standard deviation, we're going to go 1 more to the right, so we're going to add the 12 to the 107, and that's going to give us a 119. Make that look more like a 0. And then we're going to subtract the 12 from the 83, and that'll give us a 71. So now again, this is within 2 standard deviations. This is 1 standard deviation, second standard deviation to the right, 1 to the left, 1 to the right. But everything within these 2 green lines are within 2 standard deviations of the mean. Now let's say, given the mean of 95 and the standard deviation of 12, that we were asked to the nearest whole percent, it would say in the directions, to find the percentage less than 89. Well, in your calculator, you would go to second vars, again, second distribution, it says DISTR. Go down to number 2, which is norm CDF. In your lower bounds, you type in anything that's a lot less than 89. So let's say negative 999. In my upper bound, well, it's less than 89, so 89 is my upper bound. My mean was given to me, that was my 95, and my standard deviation was 12. You type all of that in, and then you press paste. You're going to get 0.3085375,322, but the directions would say round to the nearest whole percent, or they would tell you something else to round to, but in this case we said to the nearest whole percent. So this is going to be approximately 31%. If it said between 89 and 94, my lower bound would become 89, my upper bound would become 94, but my mean and my standard deviation would stay the same. So it would be norm CDF between 89 and 94, same average, same standard deviation, again to the nearest whole percent. You're going to get 0.1582556,487, which is about 16% to the nearest whole percent. Finally, we have greater than 96, so 96 is going to be our lower bound. So second distribution, norm CDF, which is number 2, 96 is my lower bound, and then any number that's bigger. Some people use 10 to the 99th power, but 999 should be sufficient. 95 is my mean, 12 is my standard deviation. You should get, when you paste this and press enter one more time, 0.4667931,809, which is about 47% if we were rounding to the nearest whole percent. Graduating seniors at a certain high school with GPAs in the top 20% are eligible for a special college scholarship. Grade point averages for seniors at that high school are normally distributed, we need those keywords there, with a mean of 2.35, that's my mean, and a standard deviation of 0.15. So we have our standard deviation, we have our mean, we want to know the minimum grade point average that a senior at that school must have in order to qualify for the scholarship. Well, students with a GPA in the top 20% are eligible for a special college scholarship. So if we were to think of this using our normal curve, students within this top 20%, that means they're better than 80% of the rest of the students in that school. So what we're actually looking for is the 80th percentile. Now when you're given the percent and you're looking for the number, so in this case we're looking for the minimum grade point average, we're going to use inverse norm. So when you have your calculator out, you're going to press the second button, and then you're going to press the VARS button. It's right next to the clear button, and you can see it says DISTR at the top of it. It's for distribution. You're going to go down to number 3, which is inverse norm. Now our area is the percentage. It's the area under the curve. Well, if we're in the 80th percentile, our area is going to be 0.8. Our average in this case, it told us, was 2.35. So that's what goes in the mu. We know that mu is the same thing for these purposes as the mean. And that's our 2.35. And our standard deviation is the 0.15. You're going to press enter on paste, and then enter one more time to calculate, and it's going to tell you 2.476243185. The minimum grade point average that a senior at that school must have, well, depending on what they tell you to round to, you might tell me a 2.48 because that's what it looks like. Everything else is being rounded to the hundredths. But when in doubt, leave all of the decimals on the screen unless it actually makes sense to round if you're talking about money or if they give you a decimal point to round to. But that means this is the overall GPA that they must have to be in the 80th percentile. A random sample of 60 female members of health clubs in Los Angeles showed that they spend on average 4 hours per week doing physical exercise with a standard deviation of 0.75 hours. We want to find the 95% confidence interval for the population mean. So a few important pieces of information here. The standard deviation is 0.75 hours. They spend on average 4 hours per week, so my average is going to be 4 hours per week. The number of people in the random sample is 60, so n is 60. And we want to find a 95% confidence interval. So in order to do that, we need to know our margin of error. So 1.96 times the standard deviation over the square root of the number of people, in this case, number of female members. So this is 1.96 times standard deviation is 0.75 over the square root of 60. You're going to type that into your calculator. And this is going to give me, without rounding, 0.189776184. So that's my margin of error, which means that my confidence interval is going to be my average, which we also use for mu here to represent the population average. So mu is going to be in the center, and then mu plus the margin of error is the top bound, and mu minus the margin of error is the bottom bound. Well, mu in this case is in between 4 plus 0.189776184 and 4 minus 0.189776184, which gives me 3.810223.816. So this is my confidence interval. If they ask me for my margin of error, I circle that as well. But that's the number of hours on average that the general population spends per week doing physical exercise in Los Angeles area.